Hi everyone, welcome back to Spring into Math 7. I'm Mrs. Campbell, and today we're going to be talking about the properties of multiplication when we're using rational numbers. Let's dive in. Hi everyone, welcome back to Spring into Math 7. I'm Mrs. Campbell, and today we're going to be talking about the properties of real number multiplication. Let's jump in. Okay, so the first property that I want to discuss, and we've talked about this on a couple of occasions, is the commutative property. And the commutative property tells us the order in which two real numbers are multiplied does not affect their product. So essentially, A times B equals B times A. We can switch the order and we'll have the same product. Here's an example with actual numbers. We've got -3 times 2. Well, that's going to equal -6. And 2 times -3, see how I just switched the order there? That's still going to equal -6. We also have in multiplication the closure property, and the closure property tells us that the product of any two real numbers will result in a real number. So A times B equals C. An example using numbers would be -6 times 3 equals -18. And the result of that multiplication problem using the closure property, the product is a real number. All right, we also have the associative property in multiplication, and this tells us the order in which 3 or more real numbers are multiplied will not affect the product. So if I group together A times B, then multiply C, I will have the same product as if I were to take A and then multiply it by B times C grouped together first. An example using numbers, I have -3 times 2 times 2, and that gives me -12, is the same if the -3 and the 2 are grouped. It's going to give me the same result as if I were to say -3 times the 2 times 2 for grouped first gives me also -12. And that is our associative property when we're multiplying. We also have the multiplicative identity property, and this simply says that when any number is multiplied by 1, any real number is multiplied by 1, the real number does not change, hence the word identity. It is itself. A times 1 equals A. An example would be 8 times 1 equals 8. 150 times 1 is 150. So any number, any real number, times 1 is itself. The multiplicative inverse property tells us if A is a non-zero real number, the multiplicative inverse of A is 1 over A. So it tells us that A times 1 over A equals 1. Now I want you to take a look at this problem here. This says 7 times 1 over 7 equals what? What we're looking for is that going to equal 1? We're going to try to determine if this multiplicative inverse property is in fact true. Now what I really wanted to show you is, let's take a look at this 7. Okay? 7 being a whole number. If I wanted to put that into a fraction form, I would write it as 7 over 1, correct? And that's what I've done here. Okay, so 7 over 1 times its multiplicative inverse, so the inverse of 7 over 1 would be 1 over 7. And what this property tells me is if I multiply this number times this number, I will get 1. Is it true? Yes, because, go back to my highlighter, 7 times 1 is 7, and 1 times 7 is 7. And we know that 7 over 7 equals 1 whole. All right, guys, that just about wraps it up for all the properties of multiplication when we're dealing with real numbers. Thanks so much for joining us, and we'll see you next time.